Hi, this is an example of how to compute an independent samples t-test with Excel. We're looking at problem 6 from the last exam that I gave, and you have to read the problem to understand how to do the t-test. Does fast music, tempo and beats per minute, improve physical endurance during training? That is the research question. A recent report claims that it does. Imagine a study that had 30 subjects randomly assigned to walk on a treadmill at a brisk pace for as long as they could. That sentence gives you the clue that this is an independent samples t-test because of random assignment. The individuals in each condition are independent of everything else because they were randomly assigned. Half of them were randomly assigned to listen to fast tempo music on headphones. The other half were the control subjects, and they listened to white noise on headphones. Their endurance was measured by the number of minutes that they walked on the treadmill. Number of minutes is a good ratio measurement. So I have the data below, and I have cut and pasted the data into Excel. Now, in order to compute the t-test with Excel, we're going to use the stat pack. The data analysis in the stat pack allows us, first of all, to compute descriptive statistics, and that's always a good thing to have. So I'm going to say descriptive statistics, and I want it first for the treatment condition. So I've highlighted them all, and I've got labels in my first row. I've collected that. Then I have to say where I want the output. I think I want the output, and I have to click in the output, otherwise it'll change my input range. I want the output right here. So I'm putting it right there. I'm asking for summary statistics, and I'm also asking for confidence level of means because that's useful if you want to plot the means with confidence levels. So I said, okay, and it didn't work. So it didn't like that. Everything else seems fine. I say, okay, and I've got the descriptive statistics for the fast tempo condition. And this is a good set of descriptive statistics. You need to be familiar with what all of these mean and how to interpret them. If I want to do the descriptive statistics for the control group, which of course I do, I'll do it again. I'll say OK. And this time I'll choose the control condition. And I've got labels in the first row. The output range needs to be a different output range. So I changed that, and I asked for the summary statistics. And I've got them for the control condition and the fast tempo condition. Now, something I want to draw your attention to is the variance. One of the assumptions that you have to make for a certain version of the independent samples t-test is that the variances between the two conditions are equivalent. Well, in this particular example, the standard deviation for the tempo condition, fast tempo, is 13.5 compared to an 8.4 for the control condition. There's a way to test that, but it's more advanced, and so we'll cover it later. So for now, we're going to eyeball this and say those don't look very different at all. Probably we need to use a t-test that does not assume equal variances. In order to do that t-test, we're going to call on the data analysis again and scroll down to the t-test. We have 3 t-tests, paired samples. Well, these are independent samples. So t-test 2 sample, assuming equal variances. No, we want the one assuming unequal variances because we've looked at the variances and they don't look very equal. We say OK, and we have to highlight the range. So the first range is our first data set. The second range is our second condition. Be sure that you get them all in. The first row is labels. Our alpha level is 0.05. And then I have to tell it where to put the output. I'm putting it down here in B20, so it's below the data. And I just say OK. And I get all of this output. So it's giving me the means for each condition, which I would need to be able to interpret any t, which is a test of the difference between means. The variance for the two groups, the number of observations, always check your n. The hypothesis was that they would be equal. That's the null hypothesis. And the degrees of freedom are 23. So this is because we have assumed unequal variances. The degrees of freedom are calculated differently when you assume unequal variances. So let the calculator function do that for you. The t-value is 2.416. The probability one-tailed of getting this, and we did have a one-tailed test, is 0.012. So it's less than alpha. This is a significant result. This is redundant, the critical tail. If you were using the critical value, you'd have to say, well, is my observed t-value, 2.41, greater than the critical t, 1.71? Yes, it is. So these two numbers are basically redundant. They're giving you the same answer. Suppose you got the opposite of what you predicted. You'd need to use a two-tailed test. Or if your original alternative hypothesis was two-tailed, then here's your P for two-tailed hypothesis and the critical value for two-tailed hypothesis. So basically, that's how you calculate a t-test for independent samples with Excel.